Hello everybody, we're back to coding, and today we're going to do the map class. And so we're finally going to well, let's run what we have so far. What we have so far is just this. Today we're finally going to draw the maps, implement platform detection, the physics of the game, and a lot more things, whatever we can fit in 2 hours. So without further ado, let's begin. Okay, so what we're going to do is in our map, we're going to have a private array of map sections. I'm going to call it sections. Right, and we still haven't created the map section class. Now, what a map section is, the way we're going to define it, so map components, we're going to go new class, and we're going to call it map section. So let me just show you visually what we're going to do. And this is going to implement and before I begin creating our map, our implementation of a map, I just want to let you know about LibGDX's tool that'll make your life easier if you so choose to use it. And that is the, if you go here, maybe tools, no, graphics, 2D graphics, and here, tile maps. Now, you can use tiled, and as a matter of fact, for this game, I highly recommend that you use tiled to render your maps, and it even takes care of platform detections for you. So, but for this game, for this small game, I am not going to use tiled simply because I'm just going to use what I'm using for my other project, Heroes of a Lost World. Now, the way we're gonna make our maps is a little bit more involved. It's a little bit more work, but you have a lot more control over what you get to do. We're gonna do everything manually, meaning we're not going to use a GUI, but we're just going to use, we're going to use GIMP and then store the points manually ourselves. But we're not going to be using XML simply because, again, rapid prototyping. You can make the functions first, hard code everything in, and then once you have a set pattern, then you can create you can use JSON or whatever to store the files, and then just create a parser, and then feed that into a method which will generate maps. But for now, we're just going to hard code everything in and do everything manually. Now, there has been something on my to-do list that is definitely going to happen once I have the time to do it. It's going to be another small project of mine, and what it's going to be is going to be a map creator specially made for my game. Now, you must be asking, well, why don't you just use tiled? Why not just use tiled? I don't want to use tiled because I feel like, I don't know, it's just preference. I just don't want to use tiled for my Heroes of a Lost World game. I just don't think it works out properly for my Heroes of a Lost World. But for this game that we're making now, it works perfectly. But still, we're not going to use it. I mean, I'm not going to use it. So if you don't like that, then go away. Okay? All right. Let me just create new. Now let me show you how what I mean by map section. What exactly is a map section? What am I talking about? Like, all right. Now let's say this is our map. Let's say our map is a 480 by 320. Right? Now we can split our map into sections so that the search time is a lot. That was bad. So let me just use paths. So we can split our map, say, from here to here, call this section 1. From here to here, call this section 2. From here to here, call this section 3 and 4. Okay? Okay, so say this is let's call this map section number 1, map section number 2, map section number 3, map section number 4. Within these map section, you can even divide this into, instead of 1, 2, 3, 4 map section, you can even say 1, 2, 3, 4, 5, 6, 7, 8 map sections. You can. This is how we're going to do it. I mean, this is how I do it. And what this allows us to do is, for each map section, we're going to have map pieces. Now, for each map pieces, so let's say we have a map piece over here. For each map piece, a map piece is going to contain information. What information is it going to contain? It's going to contain, well, in this map piece, what textures are in this map piece? And what platform information is in this map piece? Does it have slopes? Does it have just ordinary platforms? Does it have walls? And we're going to be creating these map pieces, and for each map section is going to have one or more than one map piece. What this allows us to do is, no matter how big our map is, even if we duplicate this, say 4,800 by 3,200, our search time for each piece is still going to be very small, because in general you don't want to draw for each tile. You don't want to call the draw call for each tile, because again, you're not going to be seeing the entire world at any given point in time. You're only going to be seeing a part of it. So say this is our camera, right? Now you got to pay attention. This is our camera, and in order to optimize our code, we don't want to draw anything that's outside our camera's rectangle. So what we're going to need to do is search every, if we're not partitioning it like this, we're going to have to search for every tile piece. We're going to draw it. And what if your map is this big and you have like 1, 2, 3, 4, 120 tiles? What you're going to draw? What you're going to call the draw method for each of those tiles, even though you're only seeing about, I don't know, 15% of it? No, I think that's a waste of CPU. So what we're going to do is we're going to partition it like this, and you can be the way we're going to do it is going to be very flexible, right? It's not going to be a set width. You can have whatever width and height you want, and you can in any case, so say this is our camera right here, and we're moving it around. Say at this point our camera intersects map section number 3 and map section number 4. That means that what we're going to do is that we're only going to draw whatever's inside map section number 3 and map section number 4. But that's not it. But that's not all. Let's say we have, in this map section number 3, we have a map piece over here, map piece over here, a map piece over here, another one over here, and for number 4 we have a map piece over here. Now, and let's say our camera is this. So what's going to happen is we're going to search map section number 3 and map section number 4. In map section number 3, we're going to search which map pieces overlaps our camera. So we see that this map piece over here, this map piece overlaps our camera. So that's the only thing that we're going to be drawing. We're not going to be drawing this map piece over here or these two over here. So as you can see, I think that it really lessens the amount of draw calls that will be called, instead of just drawing the entire map, which has like 100 and 200 tiles, right? I think it's very inefficient. I don't know, maybe it's just me, maybe I'm stupid, but I don't know. But that's the way I'm going to do it. If you don't like it, stop watching the videos. Alright, so without further ado, let's create a map section. What a map section is going to have? All it's going to have is an array of map pieces. We're going to call it pieces. And it's going to have a rectangle. Still need to create the map piece. The map piece is going to be quite a big class. It's going to store a lot of information. Okay, so let's import this in map in our map section. So map section. We need to know where to put this map section in the scene. So, and give it the width and height, which we're just going to feed into our rectangle. And let's create another constructor, because why not? So we have you either want to create a rectangle and just pass it in here, or you just want to pass in the points and let this create the rectangle for you. Otherwise, it's the same exact thing. Alright, and in here all we're going to do is, if our camera's rectangle overlaps this map piece's rectangle, then we're going to draw this map piece's, this map section's map pieces. Now let's head on over to our map piece, and this is going to implement now also a map piece is also going to have a rectangle. It's also going to have an array of atlas region. And for each atlas region, we need to know relative to this, relative to object coordinates. Well, you'll know what I mean. You'll know what I mean once we get to doing it. For now, just trust me, just write whatever I'm writing. Now these two x and y coordinates will correspond to the position of each atlas region, of each texture, of each of each texture that we're going to be rendering. Okay, so and then another one, and this will contain our platform information. We're going to have horizontal platforms. We're going to have vertical platforms, wall. Vertical, yeah, it's called vertical. And we're going to have slopes. Yes, we're going to have slopes. And our slope implementation will be a little bit, it's not going to be perfect. It's going to be flawed, as a matter of fact. But nonetheless, it will work with, it's not going to be smooth, but it works. You'll see what I mean later on. Let's just create our rectangle here. Now just put 0, x0, y0, and just pass in the width and the height. And what we're going to do here is we're going to draw. So remember here in our map section, if our map section overlaps our camera, we're going to draw all the pieces. But in our pieces draw call, we're only going to draw the piece if, again, the same thing. However, instead of pieces, you got regions, and it's actually length. All we're going to do is batch.draw regions I. Yeah, that's it. Alright, we're not going to scale it. Okay, so this will only draw this map piece if it overlaps the camera's rectangle. I mean, which one is more expensive? Checking if, checking, having 4 checks, checking if the left is less than or equal to blah blah blah, checking if the 2 rectangles overlap, or this draw call over here. I mean, I think that this is this is a lot more expensive, right? So yeah. So choose, which one do you want? You just want to call the draw call regardless of whether it's going to be drawn or not, or you want to check first if we're actually going to see it or not. So I think this one is a lot a small price to pay for checking. Okay, now we're going to have an interesting function here. The translate. Whenever the way we're going to do this is whenever we're creating a map piece, we're always going to start at 0, 0. So if you guys have worked with OpenGL before, you'll know that objects are created in object coordinates, and then you bring that over to world coordinates. Now in a lot of cases, the world coordinates and the object coordinates are the same thing, but for here what we're going to do is whenever we're creating pieces, like for example, let's see, what is an example of a map piece? Let's take a look here. Now let's say that this is one map piece. Now what does this map piece have? It has, if we look at our resources, right? What pieces does this map piece have? Well, it has piece 0 over here, piece 0, 0, 0, 0, 0, 0. It has a piece 1 right here. It has a piece 7 over here. It has a piece number 8 over here. It has, well, you get the point, right? So that's what we're going to do. We're going to create this piece, and we're going to do it manually. We don't have a GUI yet. I mean, I don't have a GUI yet. Not yet. It's going to come though. And as I said, we're always going to start at 0, 0. Now, unfortunately, if you're using GIMP, Y grows downwards, so this bottom left is not 0, 0, but 0 max height. So we're going to have to do some subtraction sometimes, unless you know how to invert this Y ruler over here, and that would be pretty good. Let me know how to do that, please. I've been trying to do that for the longest time now. And then once we finish making a map piece, we're going to translate that by an amount X and Y, so that we can reuse the same piece over and over and over again. And all we need to do is translate it by this much. Now it might not make sense right now, but trust me, it'll make sense once we actually see the results. Now we're gonna need to move everything, all of it, this rectangle, everything, by an amount X and Y. And I'm being a little bit quiet here. Now, it's pretty self-explanatory, really. And you want to check first if our horizontal platforms is not null, because we never know. Are all map pieces going to have a horizontal platform? Maybe not. Maybe sometimes it's only going to have slopes. Maybe only vertical, not horizontal. So we're going to check first if the horizontal is not null, because if we don't, we're going to get a null pointer exception. And those things are easy to fix, but might as well avoid them now. Because it will, oh, this is a, and you'll see why. Now this part will not make any sense until I explain it to you, but first let me finish this. Okay, what does this mean? A horizontal platform is going to contain 3 points. Right? This is the way I'm going to choose to do it, because that's really all we need. All we need is a line. And what do you need to create a line? Well, you need the initial point and another point. But however, since this is a horizontal platform, we know that the this point over here and this point over here, since we know this is horizontal, their y values will be the same. So the only things that we're going to store are x1, y1, which is equal to y2, and x2, right? So this will make our platform a horizontal platform, that is. All right, so that's all this is. So let me just make a comment here. x1, and this is y1 slash y2, they're equal. And this is just x2 of these 2 points, point 1 and point number 2. So we now have a line, and this is the way we're going to store it. Now you can store it whatever way you want, it doesn't matter, but this is the way I'm going to store it. I'll just copy and paste this and do the same thing for vertical. And again, we're going to be storing these points manually until we can have until I make a map creator. Until then, I'm going to be doing it this way. Now, for my Heroes of a Lost World project, I promised that I was going to make at least 100 maps. Now, don't get me wrong, I've already created 2 maps using it this way. And don't get me wrong, I'm not going to make 98 more maps using it this way. That'll just be way too much work. I will have to, at some point, I will have to settle down and create a map creator first, like tiled, specially made, custom made for my game, because I'm a little bit OCD like that. Okay. Now for this one over here, and I think for this one over here, a vertical. What is a vertical? A vertical platform or a wall is also 2 points. So say we have a wall. Say this is our wall. So we have 2 points for a wall, right? We have let's say point 1 and point 2. What do these have in common? Let's say point 1 is this and point 2 is this over here. They both have the same x values, right? They're both at the same x value, has the same x value but different y value. So what we're going to do is we're going to store, for a vertical platform, a wall, or you can call it a wall if you so choose to, what we're going to do is store x1. Well, first we're going to store y1 right here, then store x1, and then store y2. That's how we're going to choose to represent a vertical wall, a vertical platform. So this is going to be y1, and we know that x1 is equal to x2, and this is going to be y2. So this needs to be offset y, and this needs to be offset x. And then for our slope, which is going to be the hardest part, this is going to be the hardest part of the platform detection scheme, but we can do it. For I equals to 0, I less than slope. Now for a slope, we're going to need to store 4 points, four data, 4 floats. And I'm pretty sure you can guess why. So alright, so what is a slope? Let's take a look. A slope, again, also has 2 points. Let's say point 1 and point 2. Now, point 1 has an x and y values. Point 1's x and y values are different from point 2's x and y values, right? Because this makes a platform. Okay? So this is going to be x1, this is going to be x2, oops, sorry, y2. No, y1, sorry about that. x2 and y2. Now, this is it. This is our map piece. And let's just make a comment over here, a documentation. So what we're going to do is this method, translate, is after assembling the pieces together in object coordinates, we literally translate / move to the coordinates we want in the scene with the bottom left corner of this map piece at offset X and offset Y. Right? Because again, everything starts at 0, 0. And you're gonna see what I mean by this. But this is everything. This is our map piece implementation. So we're done with here. Also done with map section. And now let's go back to our map. We're still gonna have a width and height, and it's still gonna be public. And in our draw call, all we're gonna do is we're just going to draw all of our map sections. Now, in our map sections draw call, we're going to check if it overlaps. So the map section is going to check itself if it overlaps with the with our camera. If not, it's not going to draw itself, nor any of its pieces. If you don't know what I mean by that, then go back to the beginning of this video where I explain it. So just draw all of it. It's going to check, the section is going to check itself. We don't have to do it here. And our update, we're going to do something in our update, but not right now. Now what we're going to do is we also need a map piece generator, because we don't want to be copying and pasting code all the time in order to recreate a map piece. We just want to be able to call a static method in order to extract a map piece that we have hard-coded in. Now again, since this is rapid prototyping, we're not going to be using any XML or JSON or whatever, or text files in order to store any of those information in order to avoid hard coding things, which we want. We can do that later on, but for now, because if we do it that way, if we create a JSON, we're going to need to create a parser and then parse that and pass it into our methods in order to create whatever we want to create. But for now, we're going to hard code everything in. Okay? Just trust me on this one. Alright, so let's go to our map components. What we're going to do is create a new class. We're going to call it since this is just a small game, we only need one, map piece generator. And let's say we're going to create let's say that we're going to create this map piece over here. And I already got started on it because I don't want to do it on screen. But let's take a look. Let's say this is going to be one map piece. This map piece is going to have a width of 512 and a height of 232. Okay? Now, what is in this map piece? If we take a look at these rectangles over here, that's actually piece 0. So piece 0 over here, another piece 0, another piece 0, another piece 0, piece 0, piece 0. You get the point. And we're going to do that for all of the pieces. Alright? Now, this is the naivest way of doing things, but it's also the fastest way. I mean, without using tiled. Okay, so we're going to call that bridge 1, because we might have other bridges. And with this implementation, we can also modify this. We can also use this map generator class in order to generate random, well, pseudo-random maps Well, yeah, you can call it random maps. And you'll see how we're going to do that later on. Now we're going to have our tiles, because remember, in our texture atlas we have all of these map tiles that we're going to be using in order to create our maps. That's why we called them piece 0, piece 1, 2, 3, up to 13. And that's all we have so far. So call them tiles. Now this is going to be a static class, meaning well, you can't do this. No, you can't do that. But what I mean by static class is that we don't need to construct an object of this map piece generator in order to use any of its methods. So all of the methods in this map piece generator class are going to be public static. Now in this init, what we need to do is initialize our tiles. Just so far we have, how many tiles do we have so far? We have 14, because it starts at 0. So we have 14 pieces. That's why it's 14. And for each of those, again, we're using the same atlas for everything. So that's why, so we go to our resource and we have our resource has the atlas. So I just like it, I like doing it this way, having our main class, Nekko, to be having everything public static. Now again, there's this thing in the internet where they talk about how how the public static modifier without the final modifier is not secure. However, however, we really don't care about security. Right? I mean, I don't care about security. So, and this is a game. So I don't care if it gets hacked at runtime. Doesn't matter to me. But this just makes, see how, it's so easy. Look, Nekko, if you want to access anything in here, so it's all connected by this one class. I mean, I don't know about you, but I think that's pretty cool. It's all connected, but still object oriented. So, I just find it really awesome. And piece plus string dot value of I. Okay, and what we're going to do here, this is going to be a main method that we're going to be calling. And as a matter of fact, the only method besides the init that we're going to be calling in order to generate a map piece. We're going to say get piece, and it's going to take in a piece ID, which is going to be one of these. Float offset x for where is it in the scene? What coordinates will it, will it begin at the scene? What is its bottom left coordinates in the scene, in the entire map? Well, let me just show you exactly what I mean. So let's say that a game map is going to have a size of 2000 by that, right? And let's say that we have this piece. This is what we're going to do right now. We're going to store this piece, and it's going to start at 0, 0. So what coordinates will it have in the scene? Well, let's say we don't want to put it over here. We want to put it over here for some reason, right? Well, we need to offset this. Offset it by how much? Well, we didn't change the y. We didn't change the y coordinates, so we're not going to offset it in the y. So we're going to put 0y offset. However, we did offset it in the x direction. We offset it by an amount 532. So that's what this whole shebang is. So we're trying to imitate how we usually do things in OpenGL. So we have our object coordinates, where we model our objects, in this case our map pieces, and then we have our world coordinates, our scene, where we actually translate that piece into an actual place in the scene. So that's all we're doing. It's nothing complicated. It's very simple. It's also very naive, but nonetheless it works. Okay, so we're going to create a map piece, call it piece, and new map piece. Now, this bridge is going to have a width of 512 and a height of 232. So 512.0f and 232.0f. And we're just going to return at the end a map piece. And before we return the map piece, we're going to have to translate that piece. And it's important that you call translate right before piece, returning the piece. And then in the middle here, we're gonna initialize all of the things that we need to initialize, whatever's in our map piece. Now in here, we didn't do anything about, we didn't touch region X coords, the regions, we didn't touch any of these. All we did by creating a map piece is initialize this rectangle to have this width and height. And this is precisely why we have these variables as public, because we don't want to have to be always calling get regions, get region X coords, get horizontal platform. It's kind of tedious. So that's why I have it public. I mean, you can choose to do that, getters and setters, but I mean, I really don't care. It just makes the code longer and blah. I mean, sometimes, I have to do that when, anyways, not going to talk about that. This is not a Java tutorial. I just do whatever the hell I want because I am the programmer, okay? And I'm not working in a team. So we're going to initialize let's take a look at our bridge. What is it going to have? It's going to have one horizontal platform, another horizontal platform, and another horizontal platform. So this bridge is going to have 1, 2, 3 horizontal platforms and 1, 2 slopes. Okay? So new float, array of size 9. Remember, we only need in order to store one horizontal platform, we only need 3 points. So 3 platforms times 3 points equals 9. 9 floats. And what we're going to do is the tedious part, which again, what we're doing now is it should have a GUI. It's in my project, it's in my to-do list. Now let's take a look at our very first platform ever. Okay, what are these numbers? Well, if we take a look at it over here, this is actually our very first platform, this platform over here. It starts at piece 0. Its y coordinate is 168, but remember y grows downwards, so it's going to be 232 minus 168. So let me just show you that we're not making a mistake. So it's 232 minus 168, and you get a value of 64. That's what we have here, the y coordinate. And so x1 is 0 right here. x2 ends at, let's say it ends over here, 110. And you're going to see why later on, why it ends at 110 and not a little bit over here, because this is where the slope begins. And I spent a lot of time debugging this on my Heroes of a Lost World. The slopes, the slopes were, to me, since I'm doing everything manually, were a pain in the ass. Okay, I'm not a genius, so it took me a while to get, but I finally developed a naive implementation of how this is all going to work out. And I'm going to show you it with examples, of course. But you know what? What we need to do actually is, instead of 0, let's make it -5. Why -5? Because let's check it out. Why -5? Well, let's say again we have a map of size maybe 1000, and let's say that we put a map piece over here. Right? Now, okay, what if we put another map piece, the same one? Well, it doesn't matter if it's the same one, and we connect it, right? And we offset it by this much. Now, what's going to happen is, if it's 0, our character might, because what we're going to do is our actors are going to be represented by a single point. The way we're going to detect platforms is, so we have our actor. And our actor is going to be represented by a single dot. So this, let's change the color. We're going to represent our actor by a single dot whenever we're checking for platform detection. Now, if that's our actor, what we're going to do, what's going to happen is, if that's the dot, so let's say our actor is moving this way, and then at one point it gets to this point, and then the platform ends, and all of a sudden we fall because the platform ended right over here, right exactly over here where this platform began. So that's why we have like -5. And I debugged this, and just trust me on this one. Just put an offset, so instead of the platform ending it exactly over here, right over here, our platform is going to end a little bit over here, so we get some padding. Just consider it like it's padding. We're basically just padding a little bit, so that we ensure that our character or actor is not going to fall, because we're representing our actor as a single dot. And I'll explain that a little bit more later in detail. Geez, I hope I'm explaining it properly here. It probably doesn't make a lot of sense, but okay. And let's initialize our second. So this is our first platform number 1. Let's have our platform 2, horizontal platform. Just copy and paste this. Okay, our platform number 2 is this one over here. Okay. 1 second. Okay, I'm back. Actually took a little break there. Went and eat Italian food. Anyways, what we're gonna do first is actually gonna program the points in for all of the platforms, including the slope. And then afterwards, I'm going to explain what is going on, why the points are such. So it's going to be 150, corresponding to right over here. Right, I'm not going to show you the entire thing. You guys are going to have to trust on me that I'm putting in the right points. I am going to be including this XCF file so that you guys can look at it for educational purposes. Not like I'm anyone to educate anyone else. You know, I'm not that. I'm not good at all that. In platform number 3. So how was your day, guys? Hope it's going pretty well. Mine is I wouldn't say exceptionally well. I wouldn't even say it was well. But and in here, this is the third platform, and it's 512, so I added 5 padding like I did over here. So that's why it's 517. Okay, now let's do the slopes. We're going to have 2 slopes, so that means 2 slopes. Each slope needs yeah, 8. Each slope needs 4 points. I mean 4 floats. So we're gonna be you know, I have a bad habit of closing things all of the time, even though I'm not done with them yet. It is such a bad habit. I need to stop doing it. Platform number 1 is going to be this is going to be 90.0f, 70.0f, Alright, now these points to you right now are magic, but I will explain what these points are, how I got them later on. Again, these points are just this point and then this point and then this point and then this point for platform slope number 2. Now you must be wondering, well, why is it 70? We said that, well, this is 64, right? Technically, this over here is 64. So why are we saying that our platform is going to start, our slope is going to start at height 70 from here? From here over here. Well, what about this? Isn't it supposed to be, you know, like this, intersecting with this? Well, I'm going to show you why we're doing it this way, why it's not why the slope is not connected with this. But for now, let's just finish this map piece generator so we can have something on our screen so you can see that it actually does work. So we've taken care of the platforms. Now we're going to do the textures. So let's initialize the textures. Now 16, because we need 16 pieces in order to recreate this this bridge. We need 1, 2, 3, 4, 5, 6 piece zeros. Piece 0. We need one piece number 1 right over here. We need 2, so 6, 7, 8, 9. Then we need 10, 11, 12, and then this whole thing 13, 14, and then 15, 16. Anyways, just trust me, we need 16. Yeah, we need 17 pieces, because remember that whenever arrays start at 0. Keep forgetting that. So we need 17 pieces. That's why this is 16. What am I saying? What am I saying? Sorry about that. We do need 16, not 17. We need 16. Oh man. For some reason I always get dumber after eating something. I don't know. Maybe it's just me. And initialize our X and Y coordinates for each piece in the Atlas region. Let's allocate some space there. And now what we're going to do is piece 1s. Right? So we're just going to plug these piece 1s in object coordinates. So piece 1s is going to be, well, we're actually going to create an array for these things. Now if you take notice, all of the piece 1s have the same height, which is height 0. So for I equals 0, I less than 6, because we have 6 pieces. 6 1 pieces, 6 pieces. Well, I'll just say 6. 6 count. We're just going to initialize. Oh, right. And we need that piece dot regions dot I equals tiles 0. Now remember, in our map, we need to call init in our map so that we can initialize the tiles. So let's do that. And we're only going to initialize it if because again, for this we only have one tile set, so we're only going to be loading this once. But if we have different maps, we're probably going to need to call this constructor again, and we don't want to reinitialize the map piece generator when when it's going to be the exact same thing. So we need to check if tiles equals null. If it is, we're going to initialize it. If it's not, we're not going to do anything. Okay, that's just for map transitions. So let's go on ahead over here, and of course piece dot region y chords I is this equal to 0.0f, as we said before, because all of them are at height 0. I'm talking about piece ones, by the way. We're still doing piece ones, however their x coordinates are different, so we need a j here. Then 3 I plus plus and j plus equals tile 0 dot original width. Right? We're talking about this, by the way. So why are we doing this? I mean, I don't even know if I should explain this part. This is just a simple for loop, but let me explain now anyways. What this for loop is doing, okay, we're going to do this for loop. This for loop is going to execute 3 times right here. And we're going to start at j equals to 0. J equals to 0 here, 0. And then the next time we iterate through this loop, we're going to add another one. Where we're going to add it, the x component is going to be what? Here, which is what? J equals 0, which means j plus the width of this box. That's where we're going to begin again. That's all I'm doing here. Really no magic. And I'm pretty sure you guys know that already. So instead of doing it manually 3 times, let's just put it inside a for loop. And again, this is why tiles was created. Tiled was created for exactly this purpose. You don't have to do this manually. Again, I don't plan to create maps like this the entire project development. I do have on my to-do list to create a map creator, a GUI map creator, so that I don't have to do this manually, having to look back at the GIMP image and then plotting it and then doing that. 320 because this right here is 320. So we're going to add the second set, this one over here, that starts at 320. Other than that, we're going to do the same thing that we did for this one. Okay? Alright. Now let's take care of the rest of them. All I'm going to do here, and I'm not even gonna show you all of it. I'm just gonna program it in because I think it'll take too much time. But let me just show you exactly what I'm gonna do. So we've already taken care of all of the piece ones, right? We've programmed them in. We programmed this piece in, this piece in, this piece in, all of these pieces over here. Now what I'm gonna do for the rest of them is the same thing. So for example, this piece 1, let me just show you one more example. Then I'm just gonna, where am I gonna put it? I'm gonna put it over here, right? What's the width? I mean, at what x coordinate is this? It's at x coordinate 160 and y coordinate 232 minus 168. Remember, y grows downward, so you do need to subtract the height minus the current y. So 160. But first what we need to do is initialize All right, piece dot regions. Well, anyways, that's exactly what we're gonna do. So that's piece one, but I'm gonna go in order here. I already have the points in, but just trust me on this, guys. Just write down, just type in what I'm typing in, and once I make the repository public, you guys can verify that everything is correct for educational purposes. Again, I will include this bridge.xef in the repository so you guys can check it out. Okay, you know what I'm going to do? I'm not going to actually show you this whole thing. What I'm going to do is I'm going to pause the video here so that I don't waste any time, and I'm going to program the rest of the pieces in, and then I'm going to show you guys and walk you through it and explain exactly what's going on. Okay, I'm back, and I finished programming in all of these textures, all of these tiles. So piece number 6, this piece, this plant, I put it at this coordinate, x coordinate 6 and y coordinate 64. Is that correct? No, sorry. Region 6, that's the 7th atlas region in our array of regions, but the tile that I'm using is tile number 10 for region 6, which is tile number 10 is this piece. So if we edit this with GIMP, piece 10 corresponding to tile 10, and put it at region coordinate 6 and y coordinate 64, it'll be right over here. So that's 6, and height 64. Right? So that's all that was. And I just did them for all of them. Now we are done with our bridge. Okay, we are done with our bridge. So what we're going to do now is we can actually use this bridge. So let's go back to our map, and so we don't need to do this anymore. What we're going to do now is we're going to initialize our sections equals to new array of map sections. And then we're going to add to the sections new map section. Offset is going to be 0, 0, 0.0. It's going to be the first one. 0.0y. It's going to have a width of 1024.0f and a height of 232.0f. Alright, now why did I say 1024 width? Well, I mean, you can just say 512, but in my map section, I think I want to add another one, another bridge in the same map section. So 512 times 2, which is going to be, I mean, your map sections can be as big as they can be. It can be 10,000 for all I care, right? It doesn't matter what size. But my rule is for each map section, there's always going to have to be, well, not always, but anyways, yeah, just remember that, you know, this is going to be as flexible. It's very flexible. You can have whatever width or whatever height you want for each map section. So in the map section that we're going to create, we're going to create this map section. So we're going to create a map section that has a width of 1024 and a height of 232, and we're going to put two bridges in here. So it's starting at 0, 0, and the other one starting at 512, 0, 0, right? 0.0. Okay, so this is going to be our map section, and for now this is going to be our entire map. So let's just close this. I always do this because I'm OCD. Okay, so we're going to have another, well, not another map section, but in our map section, so what we're going to do is sections dot add, get 0, because we added this so that in order to refer to this map section, you can either save a map section variable over here, or you can just say get 0. But you know what? You know, let's just say map section equal to new map section, so we can reuse this section over and over again. Okay, and what we can do here is, before adding it in, section dot one second. Right. Section dot pieces dot add, and we're gonna extract a piece from the map piece generator. We're gonna get, what are we gonna get? The bridge. Bridge 1 and 0.0 offset and 0.0 offset Y. And we're going to add another bridge like we said before, but this time at offset 512. Alright, and now we are ready to go. Oh, and for a width, we're going to say sections dot get sections dot size -1, the very last map section in the list, dot rect the x position plus the width to get the rightmost position, so to get the very rightmost edge of the map. And this one is just going to be same thing, except it's going to be Y and the height. Okay, now if we run this project clean and then run, we're going to have something like this. Yay! We have our map. Okay, now what we're going to do, oh, and I guess what we can do is well, let's close our map piece generator for now. We're just gonna keep reusing this bridge 1 for now, and we're gonna create more later on. And here it is again, guys, the points if you missed them. Well, it doesn't really matter anyways. I'm gonna once I'm done with this game in on Monday before midnight, I'm gonna, on all of the videos, I'm gonna post up a link to the repository so you guys can see the source code, follow along with it. So for now, let's just close the map piece generator, and we're gonna go to our KF Nekko, and all we're gonna do is create a method. We're just gonna call it, because remember, we're rendering everything at 70% color, because we set our target world color to 0.7, 0.7, 0.7, 1.0. So what we're gonna do is make use of the rest of the colors. See, we still have 30% colors to add in. So what we're going to do is just, we're not going to change the target color, but we are going to change the world color, but not the target world color. So what we're going to do is we're going to create this bump world color method, and it's going to take in an amount. And what it's going to do, all we're going to do is add that amount in to our to each of our components. You know what? Instead of that, might as well maybe we don't want it to be the same, right? For each color value, R, G, and B, we're gonna have an amount. Sorry, R. Copy, paste it over here. G, B. Now what we're going to do is going to clip it, make sure that it's no greater than 1, because if it's greater than 1, if the color is greater than 1, I think what LibGDX does is it takes the modulo, modulo 1. So if it passes 1, say 1.1, what's gonna interpret the value as is 0.1, which is like we don't want that. It's wrong. So we're gonna clip it. Alright, and then what we're going to do is go to our Nekko, to our cat class. And yes, guys, I do believe that Nekko is Japanese for cat. And all we're going to do is go to our combat state right over here. And then every time we execute a combat move, we're just going to bump the world by say 0.2f, 0.2f, 0.2f. So it's going to be brighter. So it's like flashing. So let's take a look at what this does. So now every time we attack, the colors will suddenly be brighter. So it's just an extra effect. I guess we're going to include an options to turn that off because it might annoy some people. Now let's take a look. Let's play around with the numbers, right? What's going to happen if we set our target world color, our initial world color, to 0.1? I was thinking more along the lines that the background is more lit than the foreground. Let's just take a look at what. So I guess what we can do is remove the background from the drawables, and don't do what I'm about to do right now because we're gonna reset it. And before we set the color to world color, we're gonna set now what happens? What? Oh, one second, guys. Again, don't undo what you just did because we're not really going to keep this. Right. Now it's going to look like a black and white game, which is pretty cool, right? So everything is black and white. So I don't know, does it look better like this, or right? Does it look better like this, or or full black? I don't know, but maybe it looks a little better if it's a little bit lighter, right? So that there's not too much contrast. Anyways, what we're gonna do is Control Z, Control Z, Control Z, Control Z, Control Z. We're gonna undo our changes. We're just gonna keep it the way it is. So make sure that the background again is in the drawables. All right. All right. And this is a little effect that we made up. So every time we execute a command, 0.777. Are you serious? What did I do? Okay, what if we're not getting any RG? What if we're not getting any blue? What's the color gonna be like? Ah, sepia tone. So I guess this is how you create the sepia tone. Like if there's no blue color, it's like sepia. Pretty cool. What if there's no green color? Interesting, violet. What if there's no red? So we might be able to play around with these numbers, right? So we're gonna play around later on with this world color and see what works best. But for now, let's keep it like this. Okay. Now what we're gonna do is actually work on our physics, because right now our Nekko's location. So actually, let's go to our location. Go to our location class, and remember this to-do that we put here. We're finally gonna set on platform to false. All right, and we're finally gonna do this wall detection and slope and platform detection. We're not going to do the wall detection yet, but we are going to do the slope and platform detection now. So let's go back to our map. And another thing our map is going to have is a platform. This is going to be our platform detection. Now you can call it another name. You can call it a detector or whatever, but I like to keep things simple and just have simple class names. It's going to be a map component platform. And what we're going to do is just pass in the sections, the map sections. Why are we passing in the map sections? Well, remember our map sections contain the pieces, the map pieces, which contain what? The horizontal, vertical, and slope. And the horizontal, vertical, and slope platforms, which we're going to be using in our platform class in order to detect platform collision detection. So let's close this for now, and let's go to our platform class. This is going to have an array of map sections. And just a map section for what do we right, no, we need this. We need this section. You'll see why. And let's just create the constructor, which is going to take in an array of map sections. Okay, let's first take care of our horizontal platform collision detection. How are we going to do this? Okay, well, first of all, let's create the method. It's going to take in an actor. It's going to take in a float, the change in x, and the change in y. dx for change in x, dy for change in y. Again, import the correct one, the actor that we made, not the LibGDX scene 2D. And this is gonna return a boolean. So what we're gonna do is first determine which map section are we currently at. Because, okay, let's take a look. Let's take a look at what's going on here. So let's say we're going to be representing our, we already said that we're going to be representing our cat as a single point. Right? So this single point, and let's say that here's our platform, right? What are we going to do? What do we need to do to detect the platform? Well, let's say that, for example, let's say that our map piece is this piece over here. Right? So let's say that we are currently in this map piece. Right? Because remember, we split our map into pieces. So what we're going to need to do is first determine which map piece are we currently at. Are we in, so let's say that this map we have two pieces. Map piece number 1 and map piece number 2. So let's say that we need to determine which map piece we're at. So if we're in here, we're in map piece number 2. If we're in here, we're in map piece number 1. And again, this is all done so that we don't have to loop through all of the horizontal platforms and slopes and vertical walls that are in the map. We're only going to iterate, we're only going to check if we hit any slopes or platforms or walls in the section that we are at, because again, we're representing our sprite logically as a single dot, a single point with no width and no height, just a point. Now what we're going to do is, again, we stored our platform as x, x1, y1, x2. So this is our, let's say this is our platform. What we're going to do is we have a speed, right? We have a y speed. So let's say we jumped and then we're going to start falling down. Now our dy, our change in y, our y velocity is negative because we're falling down. So that's going to be our dy. Now what we're going to do is we're going to check if this point right here, right in the middle, sorry, not that point, but this point over here, the feet, if the feet, the point at the feet, so instead of so we're going to be checking the feet, the point at the feet. So if this point that starts at the feet of our actor, which is actor.location.rect rect.y, and so the initial one without adding the dy is above this platform, and then after adding the dy it's less than this platform's y value, then we hit a platform. Does that make any sense? Right, let me say that again. If we're falling down, our dy is going to be negative, and our initial y value is going to be, our initial point is going to be at the feet of our actor, right over here at this point, and then our final y value, the feet of our actor, is below this platform, then we have collided with a platform. And what we're going to do is, since we collided with a platform, is we're just going to set our actor's location such that its feet is equal, the height at where its feet is at, the y location of its feet is equal to the platform's y location. Right? Simple as that. So we're falling down, our initial y value is here, then our final y value is here, then we have collided with a platform. Does it make sense? I mean, it's pretty simple, it's pretty logical, it's pretty intuitive, right? So that's how we're gonna detect if we hit a platform. So again, we're gonna set, one second, it seems that I lost my camera. We're going to set our section. We're going to pass in our actor's location, our center location, location. Should we pass in our center location or one second. Yeah. So we're going to determine where our actor is at based on the point, this point, the center X location of the sprite, and its feet, which is rect.y. That's what we're going to pass in this method set section. So center X position of our actor, and then our actor's bottom, our actor's feet. So let's go ahead and create this method. And all this method is going to have is this. All it's going to do is find the map section that our actor is currently at, so that we can search within that map section alone, so that we don't search the whole map, all of the entire section. So we're only going to search one entire section because, again, we're representing our actor as a single point, and a single point can only be in one map section at a time. Contains this point x and y. Then we're going to set our section right over here equal to this, and then we're going to break. We're going to break out of this loop. Alright? And that's all we're gonna do. Okay. Now what we're gonna do here, okay, so now that I explained what's gonna happen, let's finally get to it. Yeah, we're going to put this inside the for loop. So we're going to iterate through all of our pieces in the section that we chose. Remember, because we set our section to be the section that in which we are currently at, right? So this section now represents the section that our actor is at. Now, if this is not equal to null, then we're going to continue. Again, this is very important because not all pieces will have horizontal platforms. So we don't want any null points or exceptions going on here. So let's just all right, get I dot horizontal so that we don't have to keep calling this every time. It's gonna have a pointer horizontal pointing to whatever this is pointing to. Okay. Now for each pieces and for each j such that j is less than section, such that horizontal dot length j plus equals 3. Plus equals 3 because remember each horizontal platform is represented by 3 points. Alright, now inside this for loop, and I know it's kind of confusing, like for and then if and then for again, so it's a double for loop. Now we're going to iterate through all of our pieces, right? And we're going to iterate through all of our horizontal platforms in each piece. So that's what's going on here. Okay. Now if let's put some spaces here. Let's put a space here. Let's put a space here. Okay. No, let's put a space here and a space here. Right. Now for okay. Now if our actor dot location dot x, so our current actor's x location is less than or equal to horizontal j plus 2, meaning the right side, the right point of the so horizontal j plus 2. So if we have a platform here having point 1 and point 2, horizontal j plus 2 refers to the x value of this point over here, of the second point. Horizontal j refers to, well, let's just put that in the comments so you don't get confused. Okay, so what's going to happen is horizontal j, this is how we save the information, remember, is equal to x1 horizontal j plus 1 equals to y1 or y2. Doesn't really matter because y1 is equal to y2. And horizontal j plus 2 is equal to x2. Alright, and this is going to be pretty self-explanatory, so I'm not even going to explain. Just follow along. I'm pretty sure you can understand what is going on. And on the left side, So if it's in between the x, if the actor's x value is in between the two platforms' x value initially, or I'm just going to copy and paste this, or the actor's final value right? If this is true, what we're going to do is we're going to switch. Okay, that doesn't mean that they hit a platform just yet. We still need to switch on the well, for now, you know what, should we take care of the ceiling detection now or later? I might as well detect the ceiling now. It's not much more work anyways. Speed y direction. Okay, now case that speed is direction down. If we're falling down, if we are falling down, and if our actor dot location dot rect dot y, the feet, is greater than or equal to the horizontal platform's y value, the initial point, and our actor's final location plus the dy is less than or equal to the horizontal j plus 1, the y value of the horizontal slope, what we're going to do is simple. We're going to do a couple of things. As we mentioned before, we're going to, first of all, we're going to set our actors' locations on platform equal to true. We're also going to set our actor's location dot y, and it needs to be the y location. Whenever we're modifying anything, we're not going to be modifying the rectangle, because remember, in our update method, we're updating our rectangle based on the center location x and y, not the rectangle location. So we have to do actor.location.y and not the rectangle.y. So here it is, right? And then plus actor.location.height, whoops, dot rect.height times 0.5f. And then we're just going to return true because we hit a platform. Okay, and what if it's direction down? So just copy and paste this because it's going to be very similar. I mean, sorry, what if it's direction up? Well, then that means we're going to detect ceiling, right? Our ceiling. So instead of so say if it's less than, if our initial position is less than, and we're going to talk about the head, and the head we get the position by adding the feet and the height, right? If it's less than the horizontal initially, and let's copy and paste this, and then in the final position it's greater than the platform above, then we hit a ceiling. And so what we're going to do is we're just going to say, well, yes, we are on a platform. No, are we supposed to, hold on one moment, 1 second. Right, no, we're not going to set on platform equals true, because if you do that, then our actor is going to be sticking, it's going to be hanging on the ceiling, so we don't want that. All we're going to do is set our actor's location.y, our actor's location's head equal to the ceiling's y location. That's all. And then just right over here, if none of these are true, then that means that we did not hit a platform, and so we can just set location dot actor, location dot on platform equals false, and then we're just going to return false. And now let's actually use this. Let's actually use this method. Where we're going to use it? We're going to use it in location class. Alright? Now in our location class, what we're going to do is, first of all, let's get rid of this to do. Again, I lost my camera focus. So delete this to do. And what we're going to do is we're going to just detect. So if we didn't hit a platform, we're just going to pass in our actor and the dx and the dy. If we did not hit a platform, all we're going to do is allow our y location to change. Otherwise, we hit a platform, and inside this hit platform, remember that this hit platform is actually modifying the position of our actor's location if we hit a platform or a ceiling, and then returns true. So if that returns true, so this returns true, but then you negate it, and then you go, then this statement will not execute, meaning because we already took care of that. We already took care of determined the y location of our actor after this method call because we had a platform. But what if, okay, so this is the case if we didn't hit a platform. We just continue going up or continue going down. But if we do hit a platform, we're going to do some other thing. Now, there's two scenarios. If we hit a platform, what was our y direction? Was our y direction down or up? If when we hit, because remember, hit platform detects either a ceiling or a platform or floor, right? Now if this returns true, this will return false, meaning it's going to go in this else statement, and we're going to need to determine what we're going to do. Well, if our speed is direction down, we're just going to set our speed, our y speed at least, to 0.0f. Okay, so that when we fall off, let me just show you exactly what's going on here. And I guess, I'm spending more time explaining stuff than actually coding. We have to meet that deadline. We gotta meet that deadline. Alright, let's just draw a platform real quick, right? Oops. Now, okay, what's gonna happen? If we hit a platform right here, okay? So we hit a platform, we're on a platform, we're just setting our speed to 0 so that when we fall off the platform, our speed isn't tremendously negative. We're not just gonna walk and then fall off and then boom, because our speed was so negative because we didn't set it to 0. But if we're setting our speed to 0 and we're on a platform, so our speed is 0, but our direction is still down, so our velocity is just equal to our acceleration, not our max y speed. So when we fall down, we're not going to fall down tremendously with so much speed. We're gonna accelerate first before like that. So it's a little bit smoother, if that made any sense. If that didn't make any sense, that's okay. Else, if our direction is up, all we're going to do is set our vertical motion state equal to falling, meaning we hit a ceiling. So now what we're going to do is we want to start going down because we don't want to stick, right? Okay. Now, just like for the camera class, remember our camera class where we have our camera right here? Remember how we're keeping track of our rectangle, and what we're saying was the center X position of our camera, our camera's rectangle is always relative to the center position of our camera. And we're gonna do the same thing here in our location class. So now we have new X and Y values. So now what we need to do is update our rectangle. The way we're going to do that is simple. Right? So we have our center X position of our sprite. And what we're going to do here is dot sprite dot current texture. Dot original width, half of it, only half of it. Right? So our center X location minus half of original width will give us the left side of our rectangle. It makes sense, right? Hope you guys are following. And we're just going to do the same thing for the Y. Original height. Alright. Now, and then finally just the original width. And original height. Now it's not necessary, but it's probably not necessary to always be setting the width and the height, but you never know if the current texture is has different dimensions than the previous textures. So just do this anyways. Alright, now we're ready to actually jump up and down in flat platforms. So now we're on a platform. Okay, as you can see. Right, so first of all, let's go to our UI and HUD. Sorry, no, not HUD, but rather components, HUD input processor. And what we're going to do is just for debugging purposes, on key left, player motion state moving. So why is it not moving? It should be moving. Oh, right, sorry about that. No. Yeah, because, sorry. In this to do, what we're going to do is x plus equal to dx. And again, we're not detecting the any walls yet, any vertical platform. So now we can actually move around. If we take a look. Whoa, 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 what happened? I guess a little bit too fast. Show you that again though. What? What? Whoa, let's go. Whoa, 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 whoa. Hold on one moment. I think it's in our HUD input processor, the way we're processing the events. Motion state moving, motion state moving, and then when we let go, motion state idle. So what's going on? Okay, we can go to our location, and if we're facing left, accel left, or else accel right. Am I doing it incorrectly? These methods. Accelerating left, then decrease horizontal speed, then set the direction to left. Okay, what if it's right? X direction, decrease. Oh, that's correct. There's nothing wrong there. I don't see anything wrong here either. Wait, did we start using the accelerometer already? Let's take a look at the HUD. we didn't, not yet. So why? What is this nonsense? What is this nonsense? Whoa, whoa, no! Okay, something is definitely going on. I'm not sure if I should pause the video here or show you guys actual debugging live. Well, let me figure out what the problem is first, and I'll get to you. Okay, I found the problem. The problem was in our speed class, and there's a couple of problems here. When we're decreasing our vertical speed, and if it's less than 0, it's not max y speed, rather it's 0.0. And I'm sorry guys if you were watching the videos and you were like, what are you doing, dude? What are you doing? That's not making any sense. And in here too, so in decrease horizontal speed 0.0f. Oh man, I am so retarded. Okay, now if we run this, we should be good to go. Ah, there we are. Okay, something is still happening. Increase horizontal. What's going on here? Let me pause the video and let me just look really hard. Oh, okay. And I'm sorry guys if you were looking at this in my previous videos where we did the speed class. I might go back to those videos and oh geez, I'm gonna have to backtrack and just let you guys know of the mistake that we made. Anyways, we're still in our speed class, and I'm sorry if I made this mistake and you were watching the video and you're like, what are you doing? What are you doing? Why is it X speed? It's supposed to be Y speed. You idiot! I apologize guys, I really do. Okay, and I believe that this is it. So let's take a look. No, not yet. Okay, let's take a look now. Alright, so what we're going to do is just going to go to KF Nekko and just initialize our starting position to maybe 200. Then if you run the source, run history main, let's go here. There we are. Whee! Now we don't have a slope detection just yet, but we're gonna get there. See how the sprite is not always in the center of the camera? Well, that's because we did what we did. Although I'm wondering why it's a little bit jittery. It's probably because I'm recording. Yeah, it is jittery because I'm recording. Camtasia is very CPU intensive. So on the oh, see, we don't have a slope detection yet. That's what we're gonna do next. But let's check it out again. See what else we could fix here. Yay! All right. So let's run it again. Let's take a look at what happens if we see how the camera is not following the actor anymore once it reaches the edge of the map, because there's nothing else to draw there, so we don't want to follow it because there's nothing else. And it's the same thing that happens on the right side, right here. And notice how the background is scrolling. How, you know, the star background is like scrolling a little bit. Yeah. And so we can even go extend this for as long as we want. Our map can be as big as we want. So if you just take a look, let's experiment. So our speed class is now fixed. Before it was broken, and I apologize for that. If you were watching the videos and you knew it was broken and you were like, dude, what are you doing? You're making a mistake. I do apologize for that. I'm just human. I'm not perfect. So, okay, we've still got to do wall detection, but let's at least detect if our actor, we're not going to allow our actor to pass the edge of the map. So what we're going to do is check if actor dot location, dot rect dot x is greater than or equal to kf, well, 0 really. This is the left side. And so we're only going to change dx if we're not going to go outside the boundaries of the map. Plus the width must be less than or equal to width. And then we can change our dx. Now, if we take a look, we're not going to fall. As a matter of fact, it's not going to allow us to go any further than this. Here we're stuck a little bit. Well, that's a simple fix. There's a simple fix there. Just remove this. Else if well, what if we just remove this equal sign over here? Are we still going to get stuck? Oh, we're still getting stuck? No problem. So else if our actor.location.that is less than or equal to 0.0f. What are we going to do? Well, very simple. X plus equals, we're just going to move it a little bit to the right, so 1.0f. And else if this other condition here is backwards, else if, so make sure you switch this, is actually greater than, we passed the right side of the map, all we're going to do is nudge our x location a little bit to the left, so minus. Now if we run this, it should be no problem. See, we're being nudged to the left. Alright, oh no! And let's check on the right side if that holds true as well. Yep. Okay, pretty cool. Hey! Did I forget an equal sign? Yes, I did. See, you gotta have this equal sign over it. It's very important. Okay. It should be working now. Now, let me just show you. Let's play around with the... we're still not done with the platform. We need to do slope detection next. And as a matter of fact, that's what we're going to do next. It's going to be a little bit more involved than the horizontal platform detection. But let's take a look at over here. Let me just show you the flexibility that we have going on here. First of all, you can change this to whatever size you want. It doesn't matter. So let's say that this map section has, I don't know, 800, right? So this is going to be drawn as 0, 0. What if we add 2 more of these, right? But instead, this is going to be at around, I don't know, 300. Also 300. Right? And we initialize our position at height 500. What is going to happen? Okay, now it looks like it's the same thing, but no. Let's check it out. There's actually, oh, whoa! Did you see that? So it's pretty cool, right? Look, look, this is what we have so far. We have one over here, just like what we said. We have a bridge, two bridges over here, and we have two more bridges right over here. Right? So we can make our maps as big as possible. Now, what you want to do is you usually want to keep your map section from being too big. You want to keep it a little bit small. You want to keep it smaller. So, right? And so let me just show you. We can have infinite length map and it doesn't even matter, right? So what we're going to do is we're going to have another section equals that, and let's say this starts at 1024 because that's where we left off over here. Same width and same height, and we're going to add the same pieces in, except this is going to be offset by an amount 1024, and 1024 plus 512 is equal to 536. And you know what? Let's do it again. I'll just show you an infinite bridge. This is going to be offset by let's whip out our calculator. So 1536 plus 1024 is equal to 2560 plus 1024 equal to minus 512 equal to 3072. 3072. Let's see what happens. And of course we need to add these sections in the proper places. So here and here. Let's check out what happens. And we're getting a null pointer exception where? Here. A null pointer exception. Did we add it? It should not be a null pointer exception. No, it should not be a null pointer exception. Why is it giving me a null pointer exception? I said, no. I said, right? This should be correct. I don't know what's going on. Then sections dot add the section. Section does not add the section. Sections dot add the section. So this should be correct. I don't know why it's giving me a null pointer exception. It's giving me a null point. Wow, it really is giving me a null pointer exception. Why? What is the violation here? Man. Maybe if we set the section equal to null first. Maybe. I'm pretty sure that's not it. No. Okay. And I guess we made a little bit of a mistake over here. Whoa, am I stupid? I am so freaking stupid. This is not, well, that's not what it is anyways, but still. This is supposed to be 48. I don't know how to do math. And it's supposed to be 2048. And 2560 is this one. But that's not the problem. The problem is we have a null pointer exception somewhere for some freaking reason. We're still getting a null pointer exception. Okay, so I guess when we do this, section equals map section, I guess this makes it null, whatever we added here. That's weird. That's not supposed to happen. You know what? You know what? Let's just do it this way. Let's do it this way. Instead of doing this, what we're going to do is we're going to add these into our map sections first. Right? Add. And just put them over here. What? Right. And then what we're going to do is sections dot get 0 this is 1. So we have 3 map sections, and this is section 1, section 2, and this is section 3. And they're all going to be bridges, just at different places. So let's test it out. And we're still getting an array of, oh man, what the hell's going on here? What? Are you serious? I initialized my platform over here with the sections when I added what's going on? Null. Why is it returning null? Okay, what if it was just 1? And this is also 1. What? What is going on? 1 second, guys. 1 second. Let me just fix this. Oh, sorry about that. No, we're not doing anything wrong here. As a matter of fact, let's put it back. And it was actually just where we initialized. Well, it's actually in our platform, because what we said was we're going to initialize it here at height 500, but since that does not overlap with any map sections, whenever we're setting the section, our section remains uninitialized, meaning section equals still null. So what we're going to do here is just if section equals null, we're just going to return false. Alright, now let's run this again. We shouldn't be getting any more null pointer exceptions. There we go. Now we added 3 map sections, and each map section has 3 bridges. Okay. Alright, it works. And as you can see, our background, pay attention to the background, it's scrolling just a little bit because remember, oh, we fell. Alright, anyways. Yeah, okay. So there we go. Let's we're gonna continue on with our platform detection, and this is good for now. We still need to add in here wall detection, but for now let's not do that. Let's do our wall detection here. It's going to be another else if. Let's go to Nekko. That's we're going to do a lot of stuff here, so look forward to that in the next video. All right. You know what? Let's not make our map too big. We're going to be randomly generating our map. Of course, we're going to create new pieces, not just bridge one. So let's just keep it small for now. Okay, and you know what? We should test it out on our actual Android. All right, on our Android, what we're gonna do is okay. Before I end this video, I lost my camera focus again. Let's go to our HUD, and what we're gonna do is what we're gonna do in our HUD is we're finally gonna use our accelerometer. Now, the accelerometer in landscape mode operates this way. So when we tilt our Android to the left, it's going to be negative y. When we tilt our Android phone to the right, it's going to be plus y. What is plus y and what is minus y? Well, it's this one. So we're going to access this value via the GDX.input, the peripheral, get accelerometer y, because we're in landscape mode. And what we're going to do is, now the device is actually very sensitive. The maximum negative y is actually up to -10. If you tilt it, well, just look in the LibGDX documentation. You know what? Let me just show you here so you don't have to open up the internet yourself. So let's go to LibGDX and let's look at the accelerometer, how the accelerometer works. So let's go to Wiki and Developer's Guide. Go to Input Handling and go to accelerometer. They drew a nice picture. So here we go. So in landscape mode, we're using the y axis. So if we tilt our whoops. Okay, let's take a look here. So this is our phone in landscape mode. Is it this or this? No, it's this. All right. If we tilt it to the left, then it's if we tilt it like this, then what this method is going to return, I'm talking about this method, Accel is going to be a negative value. If we tilt it over here, it's going to be a positive value. And that's all it is. And if it's completely like this, like it's directly pointing down, it's going to be a positive 10. If it's completely like this, it's going to be a negative 10. So it's from -10 to +10. Okay, so what we're going to do, and I've tested these numbers already, and it takes, so if our acceleration is negative 0.06, meaning we're tilting it just a little bit to the left. We're tilting it a little bit to the left. What we're going to do is we're going to set our player's face state. Oh, we don't have our, we're not saving our player. We need to save our player, so this dot player equals player, and okay, so player dot face state equals face state dot left. Now we're going to set our horizontal motion state equal to moving. And if our acceleration is less than negative 1.5 f, we're going to cap it. This is our maximum acceleration. Clip it. Now, player dot location dot speed, we're going to set our maximum x speed equal to our acceleration times 5.0 f. And remember, this is speed. Speed is not supposed to have, speed is just magnitude, meaning it doesn't have direction, so this should always be positive. So we're going to put a negative here because our acceleration at any given point in here in this block is negative. Now, but else if we tilt it a little bit to the right, so our acceleration is greater than 0.6, we're going to do something similar. So acceleration is already positive. Okay, and facing right. Now this is strictly for the Android device, so at the end of this video I'm probably gonna be recording myself with my actual cell phone. So okay, else what we're gonna do, if it's in between negative 0.6 and 0.6, what we're going to do is just we're going to set our player dot horizontal motion state, and we're just going to set it to idle. Okay. Yeah, no, this is right. And we're just going to set our max x speed equal to 0 because it's not moving. Alright, and now we're ready to test this out in an actual Android device. Now, because we're setting it to idle when this is returning 0, in the desktop, when we're running the desktop, that value will always be 0, meaning if we leave that line of code over there, when we're debugging in the desktop, we're not going to be able to move left or right, right? Because, well, it's always 0. So in order to do that again, to move left and right while we're debugging in the desktop, we need to comment those out or delete them. And now we're running back up again. Now we're actually going to give the player the option to either use the accelerometer or not use the accelerometer. Or should we? Should we even give that option? Maybe we will. But for now, the way that they're going to control their character on the Android phone is not with the D-pad. It's by actually tilting to the left or to the right so that they can move to the left or the right respectively. And they're going to jump using this jump button over here. They're going to attack using this, the pause options, and again, these are just strictly used for combo execution, not for moving, but for combo execution strictly on the phone. And I guess this one over here and this one over here, we're gonna maybe use them to represent health bars or something like that. And this is like the stamina bar or something like that. That's probably what we're going to do with it. So this is going to be health bar and stamina bar. Okay, so what we're going to do is we're just going to actually put that back in, and I'm going to show you that it actually works in an actual phone. So I'm going to pause the video right here and I'll be right back.